Hello guys, and welcome to 4.3, where we're going to learn about determinants and Kramer rule. We talked this in class. Kramer rule, not that much. We're not going to care about it, but determinants are important. And we said that the determinant, I'm going to read in the box, it says it's in the book, it's associated with each square matrix. Only a square matrix will have a determinant, so it has to have the same number of rows and columns. We name it either DETA or basically absolute value of A. It's the same margin of notation, same. And we have the easy type and the more complicated type. If you have a 2 by 2 matrix, to find your determinant, you start at A and you go the diagonal AD minus the opposite diagonal BC, CD. It doesn't matter. AD minus, this is CB, I'm sorry. So, first diagonal minus the opposite diagonal. When we have a matrix that is a 3 by 3, things get a little bit more complicated. Let me move this again. I always forget to move this. There you can see me. There you go. We said when you have your matrix set up with 3 columns and 3 rows, you're going to on the outside copy. Really, you're not going to do any of this because we're using calculator. But you're going to copy your first column again and your second column again. And then we follow the same rule. It's going to be your first diagonal, AEI, plus your second diagonal, BFC, plus your third diagonal, CDH. You add all of those together, and then you go minus. If you look at this, you go the opposite diagonals, GEC plus HFA plus IDB. So you do the first diagonals, then you add the second diagonals, and you minus them. Why do we not care about this? Because I taught you, and I'm going to remind you how you do this using a calculator. I'm going to erase all this now. We're going to do an easy one first, which you don't really, it's a lot more work to use a calculator than to do the determinant. If I have the matrix 1, 3, 2, 5, and I'm asking you, what is the determinant of matrix A? This is A. Well, this is A 2 by 2. This is a lot easier to do by hand instead of wasting time with the calculator. It becomes 1 times 5 minus 2 times 3, or 5 minus 6, which is negative 1. Pretty easy determinant to find, right? If I have the other matrix, which is a 3 by 3, my matrix is 2, negative 1, 3, negative 2, 0, 1, and then 1, 2, 4. Now we're going to do it the long way first. I'm going to copy my first column and my second column, and then I'm going to go ahead and find the determinant of A. Here's what I'm going to do. On the top, I'm going to do my diagonals like this. 2 times 0 times 4, 0, plus negative 1 times 1, negative 1 times 1, negative 1, 3 times negative 2, negative 6 times 2, plus negative 12. Now I'm done with that diagonal. I'm going to do these diagonals now. 1 times 0 times 3, 0, plus 2 times 1, 2 times 2, 4, plus 4 times negative 2, negative 8, times a negative 1, positive 8. Really, what I get from here is negative 1 plus negative 12 is negative 13, minus 12, which gives me a negative 25. We did this by hand. Can you get confused by this? Yes, you can. How do we do this using a calculator? Let's remember. We go second matrix. I'm not even going to bother to show you this. You know how to do this? We're going to move over to edit. We're editing matrix A. And the first thing I know is that this is a 3 by 3. So I'm going to go 3, enter, 3, enter. My matrix is now defined. And I go and put the matrix, forget these, by rows. So I go 2, enter, negative 1, enter, 3, enter, negative 2, enter, 0, enter, 1, enter, 1, enter, 2, enter, 4, enter. My matrix is done. I go second, quit, because I need to get back to the clear thing. Now I'm going to go second matrix. Now I'm going to show you what I do. And I move over to math. And if you notice, the number one option is determinant. And I go, yep, I just hit enter. That's my determinant. I go back to second matrix. Why? Because I need to tell it I want the determinant of A. I'll close my parentheses, I hit enter. My determinant is negative 25. So when we do determinants on a 3 by 3, you are free to do it by hand or you can use a calculator. It's completely up to you how to do this. The next thing we learned in this lesson was how to find the area of a triangle using a determinant of a matrix. So let's say you have a triangle that looks like this, and I'm not going to use the actual theory part of the book, but I'm going to use the triangle. Well, let's do it the way it is in the book. They give you a triangle in a setting of 1, 2, 6, 2, and 4, 0. Okay, this is my triangle. And I want to find the area of this triangle. And you know, the formula for area is height times base times half. We don't know any of that. We would have a hard time finding it. Really, we would not have any hard time finding it. But here's the formula. It's telling you that if you take the information you have and you put it in the matrix by your first column are all of your x's. So in this case, it becomes 1, 4, 6. 1, 4, 6. My second column are all of my y's. 2, 0, 6. 2, 0, 6. And my third column is always going to be 1, 1, 1. So this, I put this in the matrix form. And if I times it by 1/2, I get the area of a triangle. We'll check it and make sure that's true. Well, I need the determinant of this, okay? That's the area, it's the determinant of this matrix. Well, here becomes 1/2 times, to find the determinant, I go second matrix over to edit. It's a 3 by 3 already. I know I'm going to go 1, 2, 1, 4, 0, 1, 6, 6, 1. I'm done. Second quit. Second matrix, go over to math. I want the option 1 to find my determinant. Second matrix again to select. I want the determinant of that particular matrix. I hit enter. The determinant of that matrix is 22. Apparently, and I put the wrong numbers down. Oh, guys, this is a 2. It's 2, 0, 2. Those are my y's. Let me go ahead and modify my matrix really fast. Oh, Lordy. Give me 1 second. 6, this is a 2 and a 1. Second quit, second matrix, math, determinant. Second matrix, what? Yep, my determinant is now 10. So really the area of this triangle is half of 10, which is 5. Let's do this very mathematically. If you look at your book, you can actually figure out what the height of this triangle from here to here is 2. 0 to 2. That would be my height. Times my base starts at 1 and it ends at 6 would be times 5. And then I have to times this all by half. This is half times 10, which is 5. If I just do area equals half times base times height, I get the exact same answer. So if you would be to solve problems like this, you would put all of your x's in your first column, all of your y's in the second column, preferably correctly, not the way I did it, and then your third column is going to be made by 1s. You get your determinant, you times it by 2, you get the area of that triangle. We have a word problem following in here, and it's giving us all kind of stuff over there about Miami, Bermuda, and Puerto Rico. We already know they're going to want to know the area. So you read the problem if you need to. I'm going to directly make my matrix in, find the determinant. I'm going to start with, and it really, I don't think it should matter the order. They have it in a certain order, and I'm trying to understand if, I think they're going from the greatest to the smallest maybe. I can't figure out how they do the order. I don't think it really matters how you name them or how you, I am very curious about that. Anyways, the book says you have 938 in Bermuda. Then to Puerto Rico you have a 900 coordinate, and then Miami is 0, 0. So Miami is 0. Bermuda Y is 454. Am I right? Yes. The Puerto Rico is negative 518. And then Miami 0, 0. And then we said the last is going to be 1, 1, 1. They want to know what is this area. What area is half of? And I need to find out this determinant, right? Now, believe it or not, this is actually a lot easier determinant to find that you think it is. But we're going to do this by matrix first. So I'm going to go so we can practice. Second matrix, all over to edit. Matrix A, it's 3 by 3. I just go enter, enter, and I go 938, 454, 1, 900, Negative 518, make sure you use the negative sign, not the minus, and then 1, and then 0, 0, 1. Second quit, second matrix. I go over to math. I need option 1, which is my determinant option. I go second matrix again and say, yep, I want to select matrix A. And then I hit enter. My determinant is negative. Well, I put something wrong somewhere. Yet again, I don't know where, because this is not what the book says it is. So let me see. 938, 900. Well, oh, this is where our problem is. And I did not even notice that your formula says plus or minus. Why would you need a minus? The minus is whenever your determinant becomes negative, then you need to times it by a negative 1/2 because your determinant is supposed to be always positive. And I did not realize that. I did get the right answer. My answer was negative 8,94484, which means at this time, I'm going to times it by, this is a times, by a negative 1/2 because I need a positive answer. So I times that. Negative 8,94484 times negative 0.5. And my answer is exactly what the book says. 447242. So keep in mind, you have to times it, and I should have told you this, I didn't pay attention. You have to times it by a positive or a negative. The only time you use your negative is when your determinant is negative. Because really, remember how we said this is the sign for absolute value? We always want to have a positive solution. This is an area. You will never have a negative area, right? We want to have a positive area. I am going to flip the page. We are leaving page 215. And we did not, and we will not, use the Kramer rule the way it's taught in the book. It's a rule that you will never have to use ever again after today. And it's a way of finding out solutions of equations, right? They teach you that x is going to be the determinant of your matrix divided, let me look at this. It's going to be that matrix divided by the determinant of A, and y will be that following matrix divided by the determinant of A, and that's how you find your solutions. We're not going to worry about it. Let's look at this system of equations. 8x plus 5y equals 2. 2x minus 4y equals negative 10. And you know, I know you hate me for not showing you this. The previous chapter when we did system of equations and I made you do them by hand. But we said in class, we can solve this using a matrix. You already knew because we did the 3 equations with 3 unknowns using that. We're going to go second matrix, over to edit. Every time you use matrices, the first thing you want to do is edit your matrix and hit enter. Let's write our matrix first. What are we looking for? We said we always just copy the coefficients. 8, 5, 2, 2, negative 4, negative 10. Luckily, everything had a number. Had an x not have a number, I would have put a 1 in front of it so I can have the coefficient. There's my matrix. This is a 2 rows by 3 columns. And you're going to have to do this by hand. I encourage you to do this all the time. Write what it is. Because now when I look at my matrix up there, I'm going to say it's a 2, enter by 3, enter. And now we're doing by rows. 8, enter, 5, enter, 2, enter, 2, enter, negative 4, enter, negative 10, enter. And we're here, right? We go second quit. We've done this already in chapter 3. Second matrix, we go over to math and all the way down to B, which says RRF, right? We hit enter. We go back to second matrix and we say, yes, I want to work with my first matrix, A. It's right there. And then I hit enter. You get the first part is your identity matrix. We talked about that. And then your solutions are x equals negative 1 and y equals 2. If you look in the book, doing the Kramer rule, you get the exact same answer. I am just trying to cut time and not teach you stuff you're not going to use in the future at all. This is what you're going to do in your homework. This is how I expect you to solve it. In your test, this is how I expect you to solve it. Just use your calculator, put in the matrix, work it out. Okay? 3 by 3 is the exact same way. You would just make it a 3 by 4 and move on. And we're going to look at an example just so we know what we're talking about. Example 5 in your book deals with three unknowns, three equations with three unknowns, y, x, y, and z. So you have compound of methane, glycerol, and water. Each one of them have different stuff in them. If you notice, in order for you to figure out how this works is each one of them should have something in it. And that would be carbon, hydrogen, and oxygen. Okay, that's how we're going to look at them every single time. Let's look at methane. It has, C does not have a little number underneath it, so it's a 1x plus, how many hydrogens? 4, it tells me. Y plus how many oxygens? Nothing. I'm just going to write 0, Z, and I encourage you to do this every single time. Altogether, it has an atomic weight of 16. How did we write this? We looked at the methane again. C does not have a number over here, which means it's a 1. Hydrogen has a 4, so that makes it a 4. There is no oxygen in methane, so I just put 0, Z, or 0 oxygens. I could have write it. Let's do it that way. 1C, 4 H's is just going to help you. And then, wow, this is going to be interesting. 0 oxygens, give me 16. Let's move into glycerol. I have 3 of carbons plus 8 of hydrogen plus 3 of oxygen. And the atomic weight is 92. For the last part of it, for water, we already know. I have 0 carbon in water, right? 0 C plus 2 H2O, yeah, 2 hydrogen plus 1 oxygen. I get 18. We all know this. If you don't, chemistry is important. H2O is water, right? Here we go. Let's write down the matrix that we have. We only keep the numbers. I get 1, 4, 0, 16, 3, 8, 3, 92, 0, 2, 1, 18. And I want to know, all in all, it says, find the atomic weight of each one. What is C? What is H? And what is the oxygen atomic value? Well, here we go. Second matrix. We go over to edit. Let's look at this really fast. I have 1, 2, 3 rows, 1, 2, 3, 4 columns. It's a 3 by 4. Let's go ahead and go 3, enter, 4, enter. Right now you have a 3 by 4. We're going to introduce them by rows. 1, 4, 0, 16, 3, 8, not 5 but 8, 3, 92, 0, 2, 1, 18. And now they're all in. Second matrix, all the way to math, over and go down to version B, or option B, RRF. Second matrix again to tell it, yes, I want to use my matrix A. And then I hit enter, and here it is. The weight of a carbon is 12. The weight of an, I think you call it an atom, I guess so, of hydrogen is 1, and for the oxygen is 16. If you look at the book, that's what you got. Now, we could have done this the really hard way and used the Kramer rule and find the determinants of 3 different matrices depending how you set them up, and we would have gone bananas. It's a lot easier to use it this way, so I encourage you to solve it this way. I'm going to go ahead and pause the video. Happy homework.